Hi, I'm Matthew Mance. I'm the project manager for United Engineers. We're talking to you today about the business park that we're going to develop in Crown Point, Indiana. So on our team, we have an environmental engineer, transportation engineer, and structural, and then myself, a water resources engineer. The first person talking today will be Addie over Zoom.
Hi, good morning and good afternoon, everyone. So this project is a two-story mixed-use building located at 1106 Maryville Road in Crown Point, Indiana. It totals 40,000 square feet with a restaurant on the first floor and apartments on the second floor, about 1718 at about 1,000 square feet each. It will be located at the southeast portion of the parcel. The alternative will have a 4-inch reinforced concrete slab for the first floor for simplicity and strength. We used ASCE 7-22 and the ASCE hazard tool for loads, including dead, live, wind, snow, and seismic. The live, wind, snow, and seismic loads are the same for all building alternatives, and the dead loads will vary with building material. The live loads are 100 PSF for the restaurant, 40 PSF for the apartments, and 20 PSF for the roof. The design follows AISC for steel, ACI for concrete, and the estimated costs are referenced from RS Means 2025. So today we will be comparing 3 framing alternatives and deciding which we should move forward with. So the first alternative is a steel frame with W-shaped beams and columns. The second floor uses a composite system with a 3.5-inch concrete slab on top of a 1.5 to 2-inch steel deck with a hardwood layer on top, which is perfect for apartments. This keeps the floor strong but also lightweight and allows for 30 to 35-foot beam spans that work great for the open restaurants that are below. It's fast to construct, flexible for future layout changes, and is moderate in cost. The lateral loads are resisted by steel moment frames in both directions, allowing for the interior space to stay free of walls or bracing. So the second option is a cast-in-place reinforced concrete frame. The first floor is the same 4-inch reinforced concrete slab, and the second floor uses a concrete slab topped with a wood block finish. This setup provides great fire resistance, sound insulation, and long-term durability, which is ideal for separating the restaurant below from the apartments above. The lateral loads will be resisted by reinforced concrete shear walls. It is heavier and slower to construct, but does offer overall greater stability and lower maintenance over time. So the third option is a hybrid system that combines steel beams and columns with wood joists for the second floor. While this alternative, it does reduce overall weight and cost, it does have a couple concerns. Some of these concerns being that wood joists have vibration issues under residential loads. They're also vulnerable to moisture and need extra fireproofing to meet code requirements. It also makes detailing connections more complicated between the steel and wood members, which could make construction time increase. For these reasons, the hybrid option has been eliminated from further design considerations. So here's just a general summary table comparison. The steel frame provides the best speed and flexibility, which is ideal for large open areas like the restaurant. The concrete frame provides great fire safety and stiffness, but overall it increases the cost and construction time. The steel and wood hybrid alternative, even though it can be the cheaper option, it doesn't meet durabilities for this type of mixed-use building, especially with there being a restaurant on the first floor. So now that we've compared 3 different alternatives and estimated the different costs, the next step would be to design floor plans, figure out exact sizes for the main building parts, and complete the final structural layouts. After that, the building alternatives will be ready for the final drawings.
Hello everyone, I'm Andrew Webb. I'm the transportation engineer for the Crown Point Business Park project. So the first step in designing the transportation network for the site was to create a main road running through the site. So we have chosen to connect Merrillville Road on the west side to Indiana Avenue on the east, with the main road running through the site. And we have also provided a secondary access road to provide access to some of the parcels in the southwest quadrant. So we split the site into 24 parcels, each roughly 2 acres, and we have chosen a parcel right here to develop. This parcel will be 1.9 acres. So this main road through the site is designed for a 30-mile-per-hour design speed. This is typical of many similar developments in the area, and the speed limit matches the existing roads that are nearby the site. So the intersections at each end of this new road are designed for single-unit trucks, although a WB50 truck will be able to fit through the intersection if it encroaches upon the opposite lane. But there are not expected to be many of these trucks, so this shouldn't be too much of an issue. Along Merrillville Road, which is shown in this picture here, I have added sidewalk connections from the new road to Merrillville Road. At the other intersection on Indiana Avenue, there currently are no sidewalks, although these may be added at a later part of the project. So the new road, in accordance with the Crown Point standards, will have a 31-foot width, including curb and gutter. It will have 5-foot sidewalks for a total right-of-way width of 60 feet. The road will be constructed using hot mix asphalt, and the sidewalks will be made of concrete. So the vertical profile for the road is fairly flat with only a 5-foot elevation difference between the highest and lowest point. The highest point occurs at Merrillville Road at 697 feet, and then the lowest point is shortly after that. So the minimum slope of this road is 0.3%, which is the NDOT minimum standard to allow for proper drainage, and the maximum slope used in this profile is 2%. So the next step in designing the transportation network for the site was to conduct a traffic impact study at Indiana Avenue and Merrillville Road. This intersection currently is a 4-way intersection signalized. It's currently operating at level of service C, which means that there's a moderate amount of delay, but nothing too bad. And level of service C is what we will be trying to maintain with the new traffic levels. So we conducted a traffic impact study and found that one parcel with apartments and a restaurant will generate 184 new trips during the PM peak hour. And if we multiply this by the 24 parcels in the site, this gives us over 4,000 new trips total. Since there are multiple entrances to the site, we estimated that approximately 25% of the traffic will be going through this intersection, with 10% on the east and south approaches, and then 5% on the west. So we developed 3 alternatives for this intersection. The first alternative is the no-build alternative, in which we will not change any of the intersection geometry, although we did adjust the signal timings at the intersection. Even with adjusting the signal timings, the intersection is operating at level of service F, which is the worst possible level of service. And this does not meet the Crown Point requirements, so this alternative has been eliminated from further consideration. The second alternative includes adding additional lanes to the intersection. On the eastbound, westbound, and southbound approaches, a right turn lane has been added. And for the northbound approach, since there will be a lot more through traffic, we added a second through lane that will also be a shared right turn lane. This leaves the intersection with 2 lanes going northbound. So the plan is that one of these lanes will become a left turn only lane into the site. This alternative overall has a level of service C, with each individual movement also having a level of service C or better. And the third alternative for the site is a roundabout. Due to the high traffic volumes, a 2-lane roundabout was required to meet level of service C, and bypass lanes were required on 3 out of the 4 approaches. So the problem with this alternative is it requires a lot more right-of-way than the previous one, although there may be some safety benefits, so we will still be considering this one moving forward. This one also is operating at level of service C, and similarly, the northbound lanes, one will become left turn only, but then eastbound and westbound, these lanes will have to merge downstream of the intersection. So future work for the transportation part of the project includes developing drawings for alternatives 2 and 3, comparing the cost estimates for each alternative, and also designing the parking lot for the first parcel. And with that, I will hand it over to our environmental engineer.
Hi, I'm Morgan. I'm the environmental engineer for United Engineers, and we're developing a wastewater gravity collection system. So to start the design, I had to find the wastewater flow rates that will be generated on this parcel. So I went under the assumptions that each parcel on this land will be developed under the permitted uses through the Crown Point zoning ordinances. And from that, I was able to find that the total average daily flow rate is about 105,000 gallons per day. And from there, I used the water and wastewater design principle and practices textbooks, figure 18.1, which you can see on the screen, to find the ratios of the average daily flow rate to the max day flow rate and the peak hour flow rate. And with that, I found that the max day flow rate was about 327,000 gallons per day, and the peak hour flow rate was about 632,000 gallons per day. And now for my alternatives, I am analyzing where the lift stations will be. So a lift station, since this is a gravity collection system, it needs to be at a low point on this parcel. And so I found the three lowest points that are avoiding the floodplains and wetlands. And those at the north part of the parcel, it is 689 elevation, and then 689 for the other, and then 688 for the east. And then once I found those locations, I was able to analyze, and the lift station needs to be able to connect into an existing sewer system. So I have eliminated the top 2 and chosen the elevation of 688 since it is close to a road, Indiana Avenue, and we will be able to connect into the sewer system that the city already has. And from there, we know that the force main will be next to it, so that it'll be the lift station force main that will connect into the existing sewer system. And now that we know the lift station location, I have started doing the design for the pipeline routing. This is just a schematic design, nothing is finalized yet. So you can see that the road that Andrew just showed us is in red, so that is the right of way. And then just for ease to be able to see, the pipeline is in green, so everyone in the back can see it. And so you can see that we follow the right of way all the way throughout with one dedicated easement right here, so that we are able to touch every parcel with our sewer system. And then to connect to the lift station, we will be going through the easement that is already on the site, which is the NIPSCO power lines. We will be going underneath to connect to the lift station, which will then, as I said, go in and connect to the existing sewer system. And now I was able to analyze the pipe materials that will be used. There are 2 through Crown Point that were specifically called out in the ordinances. So polyvinyl chloride, or just PVC, and ductile iron. And these will be used depending on where the pipeline is finalized. So if it is between 0 and 15 feet, it will be PVC piping. If it is below 15 feet, we need to use ductile iron as to not damage the piping. As well as we need to look at the location on the right of way. So if the pipe is below the road, we should not be using PVC because it could damage the pipe. And then for the future work that we will be doing, we will be finalizing the pipe material, or the pipeline, as well as determining the manhole locations once we have finalized that, as well as designing the lift station and force main, and completing cost estimates for the design. And now I'll hand it off to our water resources.
Hi. So for the scope of work we need both a flood control plan for the entire 50-acre site and a water quality plan for our parcel of land. For the flood control plan, we need to have 0.2 CPS that is being detained per acre. So about 10 cubic feet per second is the max that can be the outflow throughout the entire site. And then on our parcel, we'll have infiltration methods that we use to reduce the TSS and the total metal load at the site. So for the flood control plan, we have 2 detention ponds. Both are in the blue. We have one in the north, parcel 3, and I believe that's parcel 11 or something like that, where we'll be containing, it's 40, or there's 43 of the total acres on the site are being caught for the water runoff. So there will be in the red, which is here, there will be about 7 acres, which is primarily on non-pervious areas that won't be caught, but will either be reduced using other BMSs or will be minimized to not be over the outflow of 10 CFS throughout the site, alongside with the outflow that will be coming from the detention ponds. There will also be 3 culverts, one right here, another here, and then another right here, and also vegetation swales that will be used to guide all the runoff from rainfall towards the detention ponds. So for the alternatives for the detention ponds, there's either wet basins and dry basins that we can use for. There's 2 major things to consider. Is the TSS removal, which is the main benefit for the wet ponds, and for the dry ponds, they're cheaper and use less space, so they can catch more water if we need to minimize the amount of space that they take up. And then there's other things to consider too, like mosquito problems being aesthetically pleasing and safety concerns, but those aren't as important as the other 2. For water quality, the main BMPs that I'll be considering are tree boxes, rain gardens, and vegetation swales, which are being used to reduce the total suspended solids. And primarily on our site, we'll be using rain gardens on the north end of our parcel to reduce and tree boxes to reduce the TSS coming from the parking lots that haven't been designed yet. And then future work for my part of the project is we need to size all the BMPs for the vegetation swales, the detention ponds, and also determining the locations that will be placed for the finalized parking lot locations and for the site runoff. Thank you for your time. Is there any questions?
I'll put Adiac on the screen.
So I have some questions. So Andrew, the one lot looks really long and narrow and a little zigzag to it.
Oh, so that one, yeah, is not for development.
Okay.
Because there's a NIPSCO easement and some wetlands there.
Okay, that's yeah, okay.
Gerrymandering.
And then you mentioned that you assume that 25% of the increase in traffic is gonna be at that one intersection?
Yes.
So how did you determine 25%?
So I looked at some of the existing traffic volumes on the nearby roads.
Mhm.
And since there's 4 ways that traffic could go in and out of the site, and all the existing volumes were fairly even, I assumed about 25%.
Okay, that makes sense. And then I was wondering about them being fairly even in the existing volumes. So, okay.
Yeah, I do have, I wrote notes down, I can't figure out what I said. If you could go to the, this is in the transportation, the typical section slide. This is a primarily residential street, is that what you're designing here, or?
Yes, so residential and commercial
So you don't,
restaurants.
but you don't know yet what the actual pavement section is? Or-
Not yet, no.
Okay, all right. But I also wanted to use this to point out that if this is gonna be the typical section, there's a lot of space that is not under pavement, so you could use PVC pipe.
Correct.
you know, unless you're crossing. Okay. On the slide that was called redesign or something like that,
In traffic?
later than this, I'll tell you. what.
New road design?
Yeah, no,
In traffic?
it must have been before this. It was still in traffic. There you go.
Oh, this one?
This one?
Nope. One more. One more.
This one?
There's a word redesign somewhere. It's not, it's in traffic.
It's in traffic.
I mean, in transportation. There we go.
Oh, there we go.
This one?
This is Indiana Avenue and Summit Street. This
Yes.
is like in the southeast
Yes.
corner. And that's currently at level of service C.
It is.
Okay. I don't remember it being that nice. But you're saying the amount of traffic we are gonna add will take that lower than C, is that right?
Yeah, we'll take it all the way down to F.
To F. That's where I thought it was now today.
You mean for the no build?
And then I was just gonna ask one general question about trip generation. How did you come up with the numbers? How many more?
Do you want to go back one slide?
I'll just hand it to you.
Yeah, so if I go to the overall site map,
Yeah.
there's this intersection here which we were developing, and then there's another intersection off the screen towards this area. So I assumed that not much traffic would be going this way because they could use this exit of the site and head towards the intersection that way. But any traffic that wants to go to the east or the south is likely going to be using this intersection. So that's why I chose 10% for those two approaches and 5% for the other one.
And the 184 new trips per building, I can see that for the site you're developing, it's a building, but if the rest of it's residential, I'm not so sure it's gonna be that many.
Yeah, so we assumed that each parcel would be the same as the one that we were developing,
Okay.
so every parcel would have apartments and a commercial use.
Okay, that's good. Let's go to, I guess it was Matthew. You had the different BMPs.
Yeah.
And there you go, you all know from class, and I'm pretty picky about stuff. So if we look at the word tree boxes, it's spelled incorrectly. Just, I want you to think you're getting past me. But I think that's all I had. Everything else is great.
So Matthew, for your flood prevention, and yeah, the pink section, are you planning to add BMPs yourself, or are you just leaving that
So,
for parcels?
right now, I'm thinking I'll either just put something in whoever wants to build on that parcel or that parcel that they need to treat their own water. For this is not for development area, right here. And then here is like the top section of another parcel, which I don't really anticipate people building that much on, just because the detention pond will be right there. So, and then if I add anything, it'll probably just be like rerouting to either a detention pond or just some other like rain gardens or whatever.
Maddie?
How did you generate this watershed diagram?
So, it was based off just the elevation map, where the water would go, and then also, I was planning on putting not detention, it's based off the elevation of the road, where the low points are right here and then here. So we're routing the water through to that thing through vegetation swales, and then we'll also have more vegetation swales up here all along the road.
And then I have a question for Morgan.
Okay.
Can you go to your pipeline routing?
Yes, I can. Oh, other way, sorry.
So for the 2 or 3 lots that are it's mostly on the west side, will those be connected to existing sewer lines? Because
Yes, those
not-
will connect to the existing sewer lines on Maryville Road, since they are just right against it.
Since we're on this slide and it shows the lot layout, and I, like Andrew, your answer was that, well, no, the one that goes with the lift
Oh, the
station,
non-
like that's where the easements are right now?
Yeah, then
Yes.
it's,
But doesn't that easement go all the way to the west?
It does.
So-
So the plan for those west parcels is that we could build a parking lot under that area. But on the east side, there's additional power lines in the middle, and there's also some wetlands, so it would be a lot harder to develop in that area.
Okay. And then I had a question for Matthew. So have you determined your flood control volume and water quality volume yet? And
So I previously did determine the volume, but then I redesigned some of the areas, so I no longer have it complete yet. So
Okay.
I'm gonna have to redo that.
do you think it's approximately gonna, I mean, do you think it's gonna change more than 10%, the volumes?
Yeah, it would, because
Okay.
I'm catching a lot more water in the
Okay.
detention ponds than
Okay.
I previously were.
So I guess I was asking that, because I'm wondering, like, are those blue rectangles are the detention ponds, right?
Yeah.
Are they anywhere close that you know of to be in the actual size?
No, I just made a thing and put it there.
Okay.
They're not sized.
Do you think, I mean, are they gonna be a lot bigger than that, do you think, or?
So when I first did the water quality volume, they're gonna be smaller than that probably.
Okay.
I sized it based off that volume. It will increase, but then I added a second one. So the first time I made it, I only used one detention pond, which didn't catch nearly enough water.
Yeah,
And I think the bottom one's size was based off that volume, approximately,
yeah, okay,
so.
okay. We have to ask Addison a
I have,
question.
I have two questions for Addison.
Okay, good, I feel better.
How will you account for sound insulation between restaurants and apartments? Or is it too early to say?
Basically, I would say vibration frequencies regarding materials. Obviously, wood does not have as great of vibration resistance, which can be a concern for residents that are in the apartments above.
Right, I'm thinking about all the noise in the restaurant when I'm trying to go to bed.
Right, yeah, so that's why I went ahead and we eliminated that hybrid option
Yeah,
for residents that are above, as well as, additional fireproofing needs that would be needed, considering it is a restaurant below.
Okay, my second question is, what time is it?
Currently, it is 4:45 in the morning.
Nice.
Normally we start later for the lectures.
I think I'm good.
Okay, yeah, good too. Okay, thanks.